Hello, welcome to Learnwizz. It's me, Linus. Hope you have done very well in your exams. In this video, we are going to discuss set 1 question papers, B and C sections. Okay, let us move on to the first question. First question is from the topic solutions, right? Yes. So, cooking is faster in pressure cooker than in an open area. So, what will be the reason behind? We know that pressure cooker, right? So there will be a lot of pressure, high pressure in the pressure cooker, right? So it will raises the temperature of the that means boiling point of the water. So what will happen? This will allow the food to cook at a high temperature. Okay, that will speed up the cooking reaction. So we can cook faster in pressure cooker than in an open pan. So it was a direct question. The next question was on mixing two solutions like two liquids like X and Y, volume of the resulting solution decreases. What type of deviation from Raoult's law is shown by the resulting solution? So on mixing two liquids X and Y, volume of decreases means which deviation? Yeah, it is yes, negative deviation. You will get half mark for that. And what change in temperature would you observe? So negative deviation, right? So what will happen to the boiling point? There will be elevation in boiling point. That means there will be increase in the temperature. Okay, increase in temperature because it is an exothermic reaction. Delta H will be negative because of the elevation in boiling point. Okay. Then next question: what is azeotrops? What is azeotrop? It's a mixture, right? It's a mixture of two or more liquids that is having same or constant boiling point, okay, and composition. That is azeotrops. Okay, so mostly what is azeotrop? Then what is the next question? Next question, what type of azeotrops is formed by negative deviation from Raoult's law? You have to give an example. So negative deviation, what type of two types of azeotrops we have studied, right? Maximum boiling azeotrops and minimum boiling azeotrops. So here negative deviation so shows maximum boiling azeotrops. Okay, maximum boiling azeotrops. And we have studied so many examples. You have to mention only one example, a mixture of acetone and chloroform is an example for it. Okay, next is it was a short question, right? It is a question from D and F block elements. Okay, so 2MnO4 minus plus KMnO4. KMnO4 is a good oxidizing agent. It will oxidize I minus to what? I minus to I2. So 10 I minus is just you will getting 5 I2 here along with Mn. So what will happen to this Mn? Mn will become 2Mn2 plus, okay, 2Mn2 plus, and 16H plus is there, so you'll be getting 8H2O. Okay, so this will be the equation, a balanced chemical equation. Okay, next is potassium dichromate reacting with Fe2 plus. It will oxidize Fe2 plus to what? Fe3 plus, right? Since it is an oxidizing agent, Fe2 plus will become Fe3 plus. 6 Fe2 plus, 6 Fe3 plus, then 14H plus. So it becomes 7 water. And what will happen to this? Cr2O7 2 minus will become what? 2 Cr3 plus. Okay. Yes. Next question. Would you expect benzaldehyde to be more reactive or less reactive in nucleophilic addition reactions than propanol? Simple question, right? So we have studied that aldehydes. In the case of aldehydes, this propanol is an aliphatic aldehyde and benzaldehyde is an aromatic, right? So aromatic aldehydes are less reactive than what? Aliphatic aldehydes. What is the reason? Because of plus R effect. Okay, plus R effect of benzene ring. Benzene ring ki plus R effect. Okay, yes. Electron donating plus R effect. Electron donating plus R effect. Okay, that will increases the electron density of this carbonyl carbon in the benzaldehyde. Okay, that is why benzaldehyde is less reactive. Okay, next question. Identify A and B in this reaction. Very simple reaction. CH3, CH2, Cl. when treated with NaCN, what will we get? NaCN means a substitution reaction, right? So it will form CH3, CH2, CN. Okay, cyanide will form, which when treated with H2 in the presence of nickel reduction, right? So you will be getting CH3, CH2, CH2, NH2. It's an amine, okay, primary amine. Next is again, we have discussed this reaction in the last video. This is a coupling reaction of formation of azo dye. Okay, yes. So this is aniline. When treated NaNO2HCl, what will we get? We'll be getting disonium salt N2 plus Cl minus, which is when treated with again aniline, right? Yes, which is when treated with NH2. It will undergo coupling reaction and you will be getting a dye, okay, yellow colored dye. So it is a test for what? It is a test for aniline, okay. Here NH2 is, okay. Yes, this is the product, okay. Then write the reactions involved in the formation of D-glucose when it is treated with HCN and Br2. Okay, it's a direct question from the textbook, right? So when we are treating this glucose, CHO, CHOH4, then CH2OH, it is treated with HCN, you will be getting what? Here is the carbonyl carbon, right? So here undergo CNOH, okay, and then CHOH 4 times CH2OH, cyanohydrin, you will get cyanohydrin. And the next reaction is with bromine water. So how will you write the bromine water equation? Yes, you will be getting gluconic acid. Okay, we have already by hearted, right? Very reactions of D-glucose. 4 times CH2OH with bromine water, you will be getting this COH will be converted to CHO will be converted to COH. Okay, CHOH 4 times, then CH2OH, gluconic acid. Okay. Now moving to the next question. A solution of glucose with molar mass is given. Has a boiling point is given. Okay. Yes. Then what is the next one? Calculate the freezing point of the same solution. You have to calculate the freezing point of the same solution. And what all things are given in this question, you have to note it down. Delta TB is given, right? TB is given that boiling point is given that 100.20 degrees Celsius. Okay. Then we know the equation delta TB is equal to KB times M molality. Okay. So using this equation, what is delta TB? And we know that this is boiling point, right? Solution of glucose in water. So boiling point of water is 100 degree. So we'll be getting delta TB as what? 0.20 degrees Celsius. Okay. Yes. So what will be M? M will be equal to delta TB by KB is given, right? KB is given. So you'll be getting 0.20 by 0.512. You will be getting the answer as 0.390. So you have got the M value. Substitute this M value in the delta TF equation. Okay, delta, we know that delta TF is equal to KF into M. And KF is already given. M, we have already obtained this M value. So KF 1.86 times 0.390. That will be equal to what? It will be equal to 0.725. Okay. Yes. What you have to find? Freezing point of the solution, right? You have to find the freezing point of the solution. You have to find how you find freezing point of the solution. We know that freezing point is 273.15. You have to subtract from that 273.15 minus 0.725. You will be getting the freezing point of the solution as 272.425 Kelvin. Okay, not much complicated, but the time consuming, right? Because two equations, same type of equation you have to use, and there is calculation part also. Okay, that's all. Okay, 2 mark. All right. Yeah. Now next is direct questions. Okay, direct questions means Colrash's law of independent migration. What is Colrash's law of independent migration? that states that molar conductivity at infinite dilution, right? Molar conductance of an electrolyte at infinite dilution is equal to the sum of the molar conductance, ionic conductance of the cation, okay, cation, and the anion at infinite dilution. Okay, so that is the equation for this is the equation for called Rush's law. Either you just write down the statement or equation, both are correct. Okay, next move into the Faraday's first law of electrolysis. What is Faraday's first law of electrolysis? Yes, Faraday's first law of electrolysis states that amount of any substance, okay, amount of any substance liberated or deposited, okay, liberated or deposited at an electrode is directly proportional to the quantity of electricity passing through the electrolyte. Okay, that is the first law of Faraday's first law. We have studied that. Okay, I think these questions are crystal clear for you to write as soon as possible. Okay, yes, that is W is directly proportional to Q. That is equation for Faraday's first law. Okay, now moving to the B question. Using these values X and Y are given, predict which is better for coating the surface of iron, X or Y. Okay, so what you have to do? Prevent corrosion, right? You have to check whether which is having more negative reduction potential. Okay, which is having more negative reduction potential, X, right? X is having more negative reduction potential. That means it can provide more number of electrons, okay, that can lose more number of electrons, so it can prevent corrosion. Okay, that's it. So simple. Next question, a certain reaction is 50% complete in 20 minutes and at 300 Kelvin, and same reaction 50% complete in 5 minutes at 350 Kelvin. Calculate the activation energy. So two temperatures are given. What is the equation for activation energy? Activation energy equation, we know what is that. EA is equal to that reaction, that relation K1 and K2. That one you have to write. 3-mark question, right? Equation is very important. Log K1 by K2. Sorry, K2 by K1. K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. Okay, T2 is given, T1 is given, and R value we know. And what we have to know is K1 and K2. How will you know that? It is given first order reaction. First order reaction, how will you find K? K is equal to 50% complete means T half, right? Yes, that you have to keep in your mind. So K1 is equal to what? 0.693 by 20 minutes, and K2 is equal to 0.693 by 5 minutes. Okay, using this equation, you will be getting this will be cancelled. 20 by 5 you will be getting 4. You will be getting log 4 value. So how will you write the answer? Log 4. Log 4 is given indirectly in the question. Okay, log 4 is equal to EA by 2.303 into 8.314. Okay, then here 350 minus 300. So 50 by 350 times 300. Okay, yes. So log 4 value you have to substitute and you have to find activation energy. You will get calculation as 24.2 kilojoules per mole. Okay, so first of all you must know this is a first order reaction and 50% complete means T half. So you can find the constant values K1 and K2 for both. Then the activation energy equations we already know. Substitute of everything in the equation. Direct answer. Okay. Yes. Moving to the question number 25. The elements of 3D transition series are given. Okay. Elements of 3D transition series are given. And scandium, titanium, vanadium up to zinc. Okay. Copper has exceptionally positive E0 value. Why? Simple question. Most of the question papers have these questions. Okay, so why it is like that? Because we know that copper, okay, copper is having a property that two important points you have to mention here. High enthalpy of atomization of copper. Okay, high enthalpy of atomization and low enthalpy of hydration. That is the two important points you have to mention here. And it's a 1 mark question, right? So no need, just you write down these points. High enthalpy of atomization. Enthalpy of atomization. That means what? We have to apply a large amount of energy to make the copper to copper 2 plus ions. Okay. Then low enthalpy of hydration means what? Low enthalpy of hydration. What is that meaning? That means copper 2 plus the energy released when copper ions are hydrated is very low. That is the thing. Yes, moving to next question. Which element is the strong reducing agent in +2 oxidation state and why? Okay, in the case of +2 oxidation state, which is having strong reducing agent means it must undergo oxidation, right? Yes. So here in this case, Cr2 plus say it is having a D4 configuration, right? And its Cr3 plus is more stable. That is D5. That is fine. Okay. Yes. Zinc also colorless. Zinc 2 plus means 3D10 completely filled d orbitals. That is why. Okay. Completely filled d orbit. Okay, move to the next question. Yeah, draw the structure of the major monohalo product for each of the following reaction. Monohalo means one halogen should be substituted. Okay, so in this case, bromine in the presence of heat. So this is a free radical reaction. Free radical reaction means radical tertiary will be greater than secondary primary. Okay, so in this case, now what will be the product? Will be like this. Cl is in ortho position and CH here will be this Br will be substituted. Okay, this is secondary position, this is primary, so here will be most stable. Okay, then this is HBr CH3. This is Markovnikov addition reaction, and negative part Br minus will go to that carbon which contain lesser number of hydrogen atom. So we will be getting the product as CH3Cl. Not Cl. Br, right? So here bromine, Br. Okay. Next question is, yes. This question is, see here, HCl and in the presence of heat. This is just a substitution reaction, but there are two OH group where to substitute that we have to mention here. In this case, OH is directly attached to the benzene ring. That is not much reactive because of the resonance stability. So what you have to do? You have to substitute here in this position. CH2Cl. Okay, that's it. Okay. Next question, how do you convert chlorobenzene to biphenyl? Okay, very simple and direct reaction. Chlorobenzene to biphenyl. It is a named reaction. Fittig reaction. Hope you know the Fittig reaction. Chlorobenzene is treated with sodium in the presence of either. Okay, that is. Then propene to iodopropane. So propene to iodopropane. First of all, you have to do anti-Markovnikov addition reaction. Okay, propene CH2 double bond CH3 in the presence of HBr peroxide. Okay. So negative part will go to that carbon which contain more number of hydrogen atoms. So you will be getting here. You will be getting this one. You will get as, after doing Markovnikov addition, you will be getting the product as Br here. Okay. Okay, you will be getting a Br here. So this is only one bromopropane, right? We want iodopropane. So what you have to do? Halogen exchange reaction. That is NaI in the presence of acetone. Okay, NaI in the presence of acetone. You will be getting what? One iodopropane. Okay. Next, 2-bromobutane to butene. 2-bromobutane to butene. It is also direct reaction of with butene. Butene, how will you form butene? Alcoholic KOH. Just add alcoholic KOH. You will get the answer. That is CH3 CH Br CH2, CH3. When treated with alcoholic KOH, okay, you will be getting what? Butene. Okay, butene. Moving to the next question. Which arrange the following compounds in increasing order of their boiling points? So here this is a secondary amine, this is a primary amine, this is an alcohol. And we know that alcohols are having high boiling point because of the presence of what? Because of the this one hydrogen bonding, strong hydrogen bonding, right? Yes, in the case of then in the case of amines, how will be the boiling points? Boiling points will be in the order primary will be greater than secondary, then tertiary there is, it is very less because of the lack of hydrogen in the nitrogen. Okay, so alcohol coming first, alcohol will be greater than primary, then secondary. Okay. Yes. Now aromatic primary amines cannot be prepared by Gabriel Thallamide synthesis. Okay. Gabriel Thallamide synthesis involves what? Gabriel Thallamide synthesis means it's a formation of amines, right? Yes, primary amine synthesis reaction. Aromatic primary amines we cannot prepare because here in this Gabriel Thallamide synthesis is a SN2 reaction. Yes, nucleophilic substitution of alkyl halides takes place. Alkyl halides, okay. The aryl halides. So for aromatic primary amines, we have to take aryl halides. Aryl halides are very much less reactive towards nucleophilic substitution reaction because of the resonance of this one. Because of the resonance of this, if it is Cl, it is resonance stabilized. So this is less reactive for substitution reaction. Okay. That is why we cannot prepare aromatic primary amines by Gabriel Thallamide synthesis. And next is amides are less basic than amine. Yes, sure. Simple question, right? Amines means it is having NH2, right? NH2 is there and it is very much available for what? Donation. In the case of amide, for example, RCONH2, due to the presence of carbonyl group, this is not very much highly electronegative carbonyl group, right? So it has a greater power to draw that electrons towards it. So it is less available. That is why. Okay. Next question, what is the difference between a native protein and denatured protein? And we know that native proteins are in the normal three-dimensional shape. Okay. Denatured means they have lost the three-dimensional shape. They have lost their biological activity. Okay, that is the difference. And so the following is a disaccharide. Yes, lactose is a disaccharide. And which is the vitamin that is responsible for coagulation of blood? Yes, it is fibrinogen. Okay. Okay, that is this much answers for this video. Okay, so hope you have done all the answers correct. Okay, yes, we will discuss the next questions in the next video. Till then, stay tuned. See you on the next video. Bye. Thank you.